Welcome class, thank you for joining me. It is our final day of chapter 9. So we're almost there, we're almost done. So let's do a really quick review of what we should have learned yesterday. So to save money for a vacation, you set aside $100. For each month thereafter, you plan to set aside 10% more than the previous month. How much money will you save in 12 months? So again, here we need to set up. We need A1, we need that rate, and we need how many terms are in the sequence. That's what we need for geometric series. So the first term, we're starting with $100. And that rate, remember that rate. So if you're setting aside 10%, that represents 0.1. But you're taking that 0.1 and you're incorporating it in with what you've already got. So that rate is 1.1. You have to add the 1 to the 0.1 you get from the 10%. And how much will you save? Well, 12 months. So we're talking about 12 terms to this series. So let's reflect back on that formula. Sn is A1, so 100, times 1 minus 1.1 to the 12th power over 1 minus 1.1. All right, so 100 times 1 minus 0.1 to the 12th power. So we are talking about negative 213.843, blah, blah, blah. 1 minus 0.1 is dividing by 0.1. So I divide that, negative 0.1. So I divide by that. How much money have they saved? $2,138.43. So again, I go through these calculations rather quickly because it's calculator technique. So the best thing you can do, again, have a calculator in front of you, pause this video, make sure that you're getting the same numbers as I am. If you're not, jot a note to yourself to check in with me during class. Now, today we are going to talk about something called divergent and convergent. So I want you to picture when your rate is 3. So picture a rate of 3. So each term, you're multiplying by 3. So each term is getting bigger and bigger and bigger. It is growing. So imagine growing forever and then adding all of that up. Well, the problem is it is never going to settle on a number, okay? An infinite version of that series will not have a sum. So we say that is divergent. And divergent will not have an infinite sum. However, let's say now you have a rate of 1/2. So every time you are dividing by 2. Now this sequence is decreasing rapidly. And decreasing rapidly, that means it actually converges. What converges means is the infinite series will actually have a sum. Okay? So, oh, I apologize. So, oh, I need to get that back. Oh, there we go. I apologize. I don't know what happened there. All right. So, to sum this up, a geometric series will converge if that rate is less than 1. So if it is a decimal or a fraction. If it's greater than 1, it diverges. It will not have an infinite sum. This brings us to our final topic, infinite geometric series. So infinite geometric series have their own special little formula, all right? And again, all you need to know is how to use it. You don't have to memorize it, even though it is relatively easy for us to use together. So let's take a look at this. So the first thing we want to ask ourselves is, do the following series converge or diverge? And for those that converge, they want us to find the sum. So this one, to go from term to term, we're multiplying by a half. So to multiply by a half, that actually is going to end up converging. So we have an A1 of 1 and our rate is 0.5. So that is going to have a converging series. So let's plug it into the converging series formula. A1 on top, so 1, over 1 minus R. 1 minus 0.5 just gives you 2. So this is actually an easier formula than what you've been doing. So let's take another look. So here our rate, our R, is going to be negative 4/5. Now, the problem with that is it is actually not going to converge. The rate is above 1, or its absolute value is above 1. So this is going to be a divergent series. That means there will not be a sum to this sequence. Okay, let's check out another one. So let's see what's happening here. So 1/2 to 3/4 to 9/8. All right, so we want to find out what if we're multiplying by something. So 3/4 divided by 1/2, multiplying by 1.5. 9/8 divided by 3/4. Okay, so this 1.5, we are consistently multiplying by it. Now again, that leaves us with a problem because we can't have that R value being greater than 1. So this is actually another divergent series. Okay, divergent because that R is too big. The R is greater than 1. Now, what about this one? So here, we're multiplying by negative 1/3 every time to go from term to term. So our R this time is reasonable. Our R we can use. Oh, our first term, our a to the 1, is 1/3. So we can actually calculate this. Okay, we can figure out its infinite sum. Again, the infinite sum, a1 over 1 minus r. So this is going to be 1/3 divided by 4/3. Now here you have to be really careful, okay? Make sure to use your parentheses when you're dividing these two fractions. 1/3 divided by 4/3. The calculator is going to tell you 0.25 is your answer. Okay, and again, I know I'm going quickly, so that means if you're not getting the same values that I am, you really, really need to be checking it out. Okay, you need to make a note for yourself to come and ask me during class. Our last example, again, anything that's inside that's influenced by the exponent is the rate. And our first term is actually 2/3 as well. You plug in 1 for n, you get 2/3. So we have R, we have A. Let's plug it into the formula. A1, 1 minus our rate. All right. Well, 1 minus 2/3. So 3/3 minus 2/3. On the bottom, hopefully you can see how we get 1/3 there. And again, when you're dividing these, make sure you're using parentheses. So 2/3 divided by 1/3. The series will converge on 2. Okay, that's what its infinite sum will be. All right, so that is it for chapter 9. So this should be the end of your notes packet. You should have everything filled out by this point. Now, again, I know I've gone really quickly through this. So again, make sure you note if you have any questions, anything that didn't quite make sense. So again, thank you so much for joining me throughout this chapter. Make sure you have all of it filled out, ready to do your practice work.